Var vi läge? Jag tror vi är läge. Har vi satt den? Good job, everyone. We need the chat. Yeah. Welcome to this year's closing ceremony for Säkerhets-SM 2026. Thank you so much for playing our CTF. We have some write-ups for you. We have some awards. We have some scoreboards to reveal. We have some sponsors to thank. Are you going to Sweden? Maybe. That's why you're watching this stream. Can everyone hear us well? Is the audio good? It's quiet. Fine. We can't hear you. We're echoing. Okay, I think someone is trolling us. The majority says that we're good. Okay, let's present. Okay. Säkerhets-SM is over. And thank you so much for playing our CTF. It's been a labor of love of like almost 20 people. And we will get even more people for the finals. Oh, shit. Oh, this is bad. You're presenting. Show my screen anyway. Ah. There we go. Thank you for flagging. Yes, so we hope that you had fun because we had a lot of fun. And we're going to start with some She's Awards. So we had a total of 10,005 total flag submissions. And some people submitted more than others. The Imposter 56 team submitted almost 1,500 flags. Good job. And we had a lot of speed in the beginning. So some Laget submitted flags a couple of seconds into the competition for flags 101. They were somehow incorrect. And GW Pro got the first correct solve. I don't know how many seconds into the competitions. I don't think that we started that.
I think we started at 01:30.
Okay, so 5 seconds in, we had our first flag. That was correct. Good job, GW Pro. And who is presenting the bingo?
I can do that. We had some of the contenders made a bingo. I'll thank Alan and Kevin for that. And we actually got the bingo, as you can see here. So
yeah, we got teapot number 1. We had challenges that broke.
You got 500.
Yep. Liam, you had some brain rots?
Yeah.
Somehow. We got 180K requests to the platform. That was before the finals. And we had a lot of GPT warriors. More about that later. So what you have all been waiting for, should we? Is this too early to reveal the scoreboard? Should we reveal it?
I think so.
Can we get ask the chat, should we reveal the scoreboard?
Shall we reveal?
No.
It's already partially. So,
yes, we're getting a lot of yes.
But if we're revealing the scoreboard now, everyone has to stay and watch the rest of the stream where we go through the competition challenges also.
It's the wager.
Okay, so we have the top two teams here in the bracket, almost. And for 418 Teapot, number 1 Sweden, that we knew before the scoreboard freeze, since they're full cleared. And then we have some other teams, but okay, who is going to Stockholm? Who is going to Stockholm? Ooh. Congratulations on your hard work and hard prompting. We look forward to seeing you all in Stockholm. And it will be the 12th to the 15th of March. And we'll sort out the logistics and travel and food and accommodation in the coming weeks, so don't worry. And we also have some recommendations for the LLM hackers. So just so you know, AI will be banned during the finals. And we ban AI because we want you to become the best hackers possible. And if you can do it with LLM, anyone can do it. So do not become an LLM wrapper. Become a real hacker. Solve all the shells without LLMs before the finals. And it will make you have much better chances at finals. Do we have any more recommendations? No.
Oh, no.
We have more recommendations later in the slides.
Lock in.
Yeah.
Yes. And if you didn't qualify, we hope that you still had fun. It's the most important thing. Trying to qualify puts you already in like the top 1% of skilled people. So just keep going, solve, play more CTFs, ask us questions. This is just the beginning. Do not give up just because you didn't qualify. We would love to bring you all to Stockholm. It's more a matter of like how many people we can afford to bring, unfortunately. So keep hacking. And now we have the first write-up.
Yes. So on popular request, I'm going to do a quick walkthrough of Gnisrever, which is like reversing backwards. It was a reversing challenge I made, and which I did provide the source code for, which perhaps in hindsight was a bit too nice because there ended up being quite a lot of solves. And I imagine having a C source file helps in prompting. But so the idea of the shell was that it's in x86, and we make a hook on processor on every instruction to make it execute instructions backwards. So whenever there's executed one instruction, it like resets and then jumps back one instruction. And so the instructions are laid out differently in memory to how they're normally done. You can skip a slide. And so if you figure out that, then it's quite easy to take all the instructions and just like put them in the reverse order, and then you get some shell code, and you try to put that into some decompiler. Here's a binary ninja screenshots. And you will notice that it does mess up some stuff because the jumps in the code, when it's trying to jump from some destination to another, it uses a relative jump. So it takes the current like position and it like adds 10 to jump to the next one. But if we reverse the instructions, then that's going to jump to a different place. So that will mess up the control flow. And so that's something you will have to account for when you're like transforming this back. Since I made the challenge, I have the source code on the next page for like the inner challenge. So we had the outer one running all the hooks and stuff, and then we have the inner one, which is like emulated via shellcode, which is a not very weird like flag checker. It reads in your flag. It has a couple of like things to confuse you. So it tributes the input, like shuffles around the letters in some way. And then it also it takes like pairwise sums of characters. It goes along the string and sums them up and then compares it to some target. And then for the final one, it will like sum 0 to the last character. And so from that, you know the last character, and you can like work backwards to recover the rest. And so if in the next slide, I think we have a solve script from Zeta 2. Yes. So if you extract all those important like buffer values, you can do this to get out the flag. Yes.
Great.
Amazing.
Thank you, Walter. And congrats to everyone who solved the challenge. And if you didn't solve the challenge, please go back and upsolve, preferably without LLMs or without too many LLMs.
Moderate amounts.
Moderate amounts.
Yes.
Pointer roulette.
Can I have the? It's going to be a lot of clicking.
Sit on the floor.
All right, we're going to do it like this. So pointer roulette. Well, it kind of looked. Oh, I didn't bother to install the compiler, so this is just the source code. You're going to have to live with that. All right. So the challenge: you can basically bet your parts of your pointer and get a random pointer. That's a lot of fun. So how do we solve this? Well, the first approach, obviously, we need to control this pointer because it's random. But since we can choose the size that we randomize, we can essentially start at 8 bytes and then go down in size until we control the entire pointer. Easy enough, so we should just be able to set the pointer, get money, easy flag, all of that. But there are some problems. So first of all, we need a leak because there's obviously ASLR. How do we do that?
What is ASLR?
Address space layout randomization. So we don't know where the binary lives in memory. How do we counter that? Well, I was kind of nice in this challenge. The pointer that we have is initialized to itself. So if we just perform a bet of something very small, we get the pointer afterwards, so we can just leak it that way. Easy. Now then. No. Yeah. So another hurdle is that we only get one right. The program will only allow. Oh, that I should have probably said that. We can randomize the pointer, and then we get one right to that address arbitrarily. But only one right, that's kind of boring. So we just overwrite the counter. That's our right. And now, boom, we can perform unlimited amounts of rights. Now, to the fun part. How do we get code execution? So we have the options to obviously randomize the pointer and then write the value. But there's a hidden option, number 67, in the code, which just takes in some input from standard in into a buffer and then encrypts it using military grade encryption. This doesn't really seem to do much, but if you observe, it calls memfrob with our user controlled buffer, which means if we were to redirect this memfrob call, we could call anything with an arbitrary string input. So what do we do with this? Well, first of all, we need to attack the global offset table. Amazing. So yeah, just take over the global offset table. We can point memfrob to any function. And through this, we can first leak libc address by just pointing memfrob to printf and then setting the buffer to some exploit format string, because there's obviously going to be libc pointers on the stack and whatever. So amazing. Oh. Are we?
We're still on the screen.
Okay.
But it already comes display.
The camera is, yeah.
All right.
Okay.
1 second.
But I think it's fine to continue.
Yeah.
Okay, let's pause.
Maybe
Technical issues.
We're back.
Okay.
Okay,
Right.
okay, Garmin.
Are we
Soon.
microphone on?
Den lyser.
Okay, can you hear us?
Hade kameran börjat lysa en liten lampa.
Yeah. Are we live?
Den började lysa för 5 sekunder sedan.
We can hear you. Amazing.
Det kanske är...
Yes, I think we're good.
Are we good?
Yeah.
Can you hear us?
Whoa!
Amazing. We're back. So,
Very nice.
yeah, the context here, maybe I'm here. All right. So now we have code execution and we have a libc leak. Now, what do? Of course, we utilize the same technique. We take over memprob and point it to system this time. And then we set the buffer to bin.sh and boom, profit.
Raise the cameras.
Yeah, that's it for me.
Yeah, nice.
And my question is, if someone wants to become an expert at this, what should they Google?
What they should Google.
Or what should they ask ChatGPT to become an expert?
That's a good question. They should ask. Where the bytes at? Can you hear me?
I hear you.
They should maybe go to Pone College.
Go to Pone College. That's some good shit. All right, let's go.
All right. Yes. Where do I press? Okay. It's time for the most requested challenge that you wanted a walkthrough on. So we have Yabna, yet another boring web app. So it's just a. I noticed that it should be Note instead of web, but never mind. So it's a classic Note app where you can create notes and view your notes and search for notes. Really boring stuff. But how do we flag this challenge? There's a note which is owned by the admin. And we can get the ID of the note by visiting API flag health check. But if we try to view the note, we get an error, which is forbidden, admin access required for flag notes. So how do we bypass that? Well, in the endpoints that we can use to view notes, both the notes ID and the search, there's an check admin, which checks that there's an admin cookie and a flag access token. The admin cookie is set in the admin bot and it's HTTP only. So it's basically like impossible to exfil unless you got some mad skills. And it's not needed since it will be sent with every request. But we need the flag access token since that's provided from the access query parameter. So how do we leak this flag access token? So in the visit node function, we see that the admin bot enters the flag access token only if we are on the flag node page. So it checks that we're on the correct URL, checks that we're on the node's endpoint, and then extracts the flag ID and checks that it's the right one. And if it's the right one, it clicks on the input field, as you can see on the bottom left image, and then enters it in the box. So how do we do this? Okay, so the first vulnerability that's pretty easy to see is the HTML injection in the nodes. So we can just pass in arbitrary HTML since it's using .inner HTML to enter the node into the element. But there's one problem here. It's the CSV. So how does the CSV look like? Yes, so on every page, there's the same CSV set. And if we pass it into a CSV evaluator, it says it's very secure, except the script source is a bit bad, because if we have some kind of file upload functionality, we could just upload our JavaScript and then create a script tag with a link to our upload if it's on the same origin. But in this challenge, there's no file upload, so it's safe. So what's bad about this CSV? The default source none basically says like we disable everything, and the things that come after it is like exceptions to it. So the script source self, we have that to like make it possible to have JavaScript. Then we have the style source unsafe inline, which enables CSS on elements. Then we have the frame source with a star, which means that we can have any source for iframes. And then we have the rest, which is not important, but style source and frame source are important to note here. So how can we use this? So yes, we have this. So the problem is we want this flag access token, but it clicks on the element with the access ID, and since we have HTML injection, we can inject maybe another tag with the same ID, but the problem is that it will always select the first element that has that ID, so that will not be possible. So we have to look a bit closer on what this .click method actually does in Puppeteer. So if we look inside the source code of Puppeteer, we see that the click method actually scrolls into view where the element is, and then clicks in the center of the element. It like does a manual mouse click.
Can I zoom in?
We have to zoom
You have to zoom on the, okay, skip
on the code.
in the minutes. If you want to zoom.
Yes. Perfect. Yes. So this means that we can use an attack called clickjacking. So what we can do is we can create an overlay on top of the whole page. So in this case, we can create an iframe to a site that we control, and then put a style that basically makes it on top of the input field. So when the admin bot tries to click on the access token input box, it actually clicks in our iframe. So yes. So if we then in our attacker page create a input tag that like takes the whole page, so with 100% height, 100 view height, then when the Puppeteer bot clicks on the flag input, it actually clicks inside our iframe and inside our input box that we control. So we can actually leak the access token this way, because it will actually enter it inside our iframe with the origin that we control. So now that we have the access token, what can we do now? Well, there's still the big problem that it only enters the flag access token if we are on the flag note ID. So we have to change the URL of the page to have the flag ID without updating the DOM, because we want our script to be untouched, but we need to update the fragments. And now I will leave over to Carl.
Yes. And thank you, Liam. A round of applause. That will hand it back to
Yes. So fragments. What are fragments? Fragments are the last part of the URL, which is we can enter a fragment by putting a hashtag. And the thing about fragments is that they are on the client side. And when we change a fragment, it does not trigger a page refresh. So we can do this, that if we create a note that points to our attacker site, and if we on our attacker site do parent dot location, we can change the URL of the parent site. And because we changed the fragment, there will not be a page reload, which is really nice. So we can change it to the flag ID, and then our Puppeteer bot will do the check and think it's on the flag note, even though it's actually on our attacker controlled note. So that's very good. How do we proceed? Yes, we can then use this little script to extract the token. So we put an event listener on our input box and just leak it. Very nice. So now that we have the access token, how do we get the actual flag? We have no script execution on the sites. We have HTML injection, but nothing more. But how can we get the flag? Wait for it. Access leaks. Oh, wonderful. So there's a technique called frame counting. And basically, in the search endpoint, for every node that matches the query, it creates a iframe for that node inside the search site. And the thing with iframes is that a cross-origin page is actually allowed to read the length of the amount of iframes that are on a cross-origin page. So what we can do is that we can open a new tab with some query, and we can check like how many iframes was created on the new page that we opened, even though we're on another origin. So how can we use this? Yeah, so we can do a kind of brute force attack. So if we look at this little script, we start with the flag format, SSM, and then we create a guess, which is the flag plus a character from our short set. And then we do window.open in the count frames function. And then we wait for some milliseconds for it to load. And then we have the const count variable, which is the amount of iframes. And then we have the check. If frame count is more than 0, we know that the flag node was matched on the search. So we know that our query matched the flag. So we can append our character to the flag and then just repeat the whole process and just get character by character for the whole flag. Yes, and thanks and Tom Sick for the nice scripts. Shout out. So yeah, a round of applause to everyone. So quick recap. We do the click yanking in Puppeteer by creating a node with an iframe, and we use inline style to cover the whole page with our iframe. So the admin bot enters the access token in our iframe. And then we can use the frame counting access leak to brute the flag character by character by opening a new tab with our query and just, yeah, brute character by character until we get the full flag. So yeah, that's it.
Thank you very much, Leon. Big applause, big applause. Great, who's next? Powertrace.
It's Leonard.
Yes.
Oh, Leonard.
Can you hear me?
And you joined the... Oh, wonderful.
Can't hear it.
Well, we can.
Okay, the stream can hear you, Leonard, but we cannot. So
Okay.
we will mute ourselves and enable our speakers so that we can hear you. And you can tell us when to push the slide. One
Sure. Okay, yeah. It's gonna be delayed, but okay. So yeah, this was Powertrace, which is, you see from the Frozen scoreboard, was the least solved cryptography challenge. And a large part of it seems to be because the LLMs just couldn't do it. So that's kind of nice. And yeah, so look at the challenge itself. I put like the real meat of the challenge on the right side of the screen. And it those who are a bit knowledgeable will recognize that this looks like some kind of elliptic curve challenge. And essentially, we have like this loop over a bunch of attempts where we get to send some input. It gets multiplied by this predictable number, which is sort of small. Then it takes modulo the curve's order and then multiplied by some point. And then what we get after that is the number of additions that were made in this double and add function. And then we print this cost. And nothing about the curve is known. Not like any modulo or parameters or order or nothing. And the goal is that we have to, after several of these steps, figure out what is this unknown variable x. And the first thing to point out there is that the elliptic curve part itself is not important. It doesn't have to be an elliptic curve at all, it would still work. However, I heard that apparently the LLMs sort of fell for it and trying to figure out what the order was, but that's not really necessary. So yeah, next screen, move it. So there are essentially two things you have to realize for this challenge. And the first thing to figure out is what does like this cost actually represent? And so if we look at the double and add function, we can see that like for one, we have this while loop, which it loops until n is no longer positive. And at the end of the loop, it shifts down n by 1 bit. So from that alone, we need to add from the Q addition, the bit length of n to our cost. But then also for every bit that is equal to 1 inside n, since remember we shift it down and we check for the last bit, we also do an addition to compute r, which is like the result of the addition, or a multiplication rather. So we also have to add the bit count when doing this. So as you can see, for example, from my modified code at the top, or from the printout at the bottom right, we get the bit count plus the bit length of, it's like x plus the multiplier times our inputs modulo the order, and that's the actual output. And this is sort of like a hint that maybe you should think about this from the perspective of like not like a big number, but rather like a stream of bits. That maybe this is like a bit more useful. And that's what we'll do. So what we're going to want to do is to like sort of scan along the stream of bits and sort of figure them out in one direction. And so the question is, do you want to start by figuring out the most significant bit and let's sort of like work our way down to the least significant, or do you want to start from the least significant bits and work our way up to the most significant? And so the thing to remember is that we have a limited amount of query to do. And therefore, going from most significant to least significant doesn't really work. So you have to do the other way. So if MoveIt wants to swap the screen, we're going to go from least significant to most significant. And so the property we'll have here is that the bit length of the number is usually constant. So it's going to be like very close to the bit length of the order, so 380. It might be a little less because, some randomness. But if we just modify the lower bits of a number, this value will not change, which means that the value that does change is the bit count. And so we have to figure out how to sort of leak bits from this change in bit count. And the way we do that is by making this is the second thing to realize about this challenge. And so I have two examples here on the right. I will sort of illustrate, and it's that, so when we add like a 1 bit, just 1 for now, to like some position, then assume we hit like some sequence of 1s, like the start of it. And then this will sort of flip. So the bit count will decrease by the length -1 of this sequence of 1s. So I have sort of like represented this on the right. We can see here on the top, I have like, if we assume that this sequence of 1s is like empty, so it's just a 0, then adding 1 will make it 1. So we increase bit count by 1, which is then 0 minus 1, right? And then I have another example on the bottom where we begin with like a stream of 2 1s. So you have 1 1, and we add 1 to it, which means that now the first bit becomes 0 because we add, and then we carry, so we get to the second bit, which was also 1 before, so now this is also 0, and so we carry again to the third bit, which is a 0, which then becomes 1. So from this perspective, we went from 2 set bits to 1 set bit, so we lost 1 bit count. So for every starting sequence of 1 we hit, the bit count will decrease by the length of it minus 1, which means that we get immediately how many ones in a row we have. And since this sequence eventually has to terminate with a 0, we also get that the bit immediately to the left of it is a 0. So with this, we can now get a stream of bits known at some index. And then if we want to flip again, we sort of get the strategy. So we have to first of all, there's also this step in the problem where we multiply the input by this index, and this means something we have to account for in our solution. So here in this picture with the numbers, I have put a vertical bar to sort of represent where the boundary between our known bits and unknown bits are. And so what we do is we know this multiplier beforehand. So we begin by setting our number back in terms of number of steps. In this case, my multiplier is 1, 1 or 3. So I put my bit I want to add immediately 1 step behind the bar, so where our last known bit is position-wise. Which means after multiplying by this number, then my number becomes 1 bit bigger, which means that the first bit now goes into the very first unknown bit, which we want to detect a sequence in. And as we see then from the example, this will trigger this streaming thing I talked about the last slide in these unknown bits. But it also triggers on the known bits. We still have 1 bit left. So that 0, which was previously known, is now a 1 in the new value. So we also not only do shift our bits size accordingly to match the multiplier, we also have to account for these known bits, which also change. But then with this, we sort of get the strategy for the challenge, which is we start with the very least known unknown bit, which is the first bit, the 0th bit. And then we add 1 to a position at that index, which we have to of course do our shifting to account for. And then we remove the known bits that were affected, which we can calculate because we know what the known bits are, and then count the difference in bit count. And then from that, we figure out, okay, how many ones and then the 0 at the end was there. And so we account for this. And then we just repeat until we eventually get all the bits, which in theory gives us pretty much everything. Now move it, flip. So there's just one thing left to figure out, or one thing left to determine, that is this actually enough to solve the challenge? And so we have 380 queries. Sorry, we have 380 bits in our number X, or maximum, and we have 200 queries. We need at least 1.9 bits per leak or per query. And I've tried to represent here on the right. So there's a 50% chance that the bit we add to is a 0, at which point we get 1 bit leak. If it was a 1, then the bit next to it will have another 50% chance of being 0, 1. So we can get a 2-bit if that was 0. We sort of keep going up to 380. So the expected leak per query with the strategy is this sum of k over 2 to the k up to 380, because that's the limit of a number. Plugged into Wolfram Alpha, we see that it's a 1 followed by a lot of 9s. So pretty much 2, which means that which is slightly bigger than 1.9. So it's just barely enough leakage to actually get a solution in the number of queries we have. So that's pretty much how to solve the challenge. There's one question that I think the LLMs got quite stuck on, which is, what about this order number in like because we modulo like the input plus like x with this like order of the curve, which is like a good idea in this normal cryptography. And what we do is we just ignore it. So we just hope that the order like wasn't triggered or it was triggered. Doesn't really matter. We're just gonna like guess what like the last bit was, or if it was triggered, then we just guess. And this will work often enough to like solve a challenge. You might need a few tries, but like it's very doable. And that's basically the challenge.
Thank you so much, Leonard. Okay, no echo. Thank you so much, Leonard. And as you can see, like a lot of these challenges are very hard. Like it's completely fine if you don't understand this walks through, and that's why they are also like recorded, so you can go back to them. Like Leonard is super smart. I don't understand all of this, but keep like practicing, keep going. Not understanding this is expected and okay. You have like 1.5 months to practice for the finals.
Yeah.
Right?
Right.
Yeah. So if you don't understand this now is the time to look in. You will get there, I promise. And then we have the next challenge. React to shell.
Yeah, so I made a challenge called Not So Explosive, which is a CV-based challenge on React to Shell. React to Shell is a CV that happened like 1-2 months ago, if I am not mistaken. But it was this, I thought of it as an introduction to CV challenges for beginners. So it's a simple Next.js website that is made by Dynamite Harry from the famous robbery group called Jönssonligan, which is a series in Sweden that's popular from like 90s. Yeah. So it just says he made a cool website, but he keeps exploding it. So there's nothing much on it. And then it says, but it's secure. Here you have the flag even. So the flag location is asap/flag.txt. Then it says which version it is made with. That's all. That's all you get. So the challenge, I would say, is really simple. Just take the next.js version. So next.js, and then the version, search it up on Google, and like add CV, search it up, as you can see there on DuckDuckGo. You get the first result there, which is just, here's an advisory, some shit has happened, it's not great, you should upgrade your versions, which apparently Dynamite Harry has not done. Update your dependencies. With this information, you can either just make your own solution based on what the CV tells you, or you can get a working proof of concept. But the basics of this challenge is just that React and Next.js uses a format to communicate objects between the server and the client, which I cannot remember the name of right now, but it's there so they know, okay, this is the object that we're looking for, here's the data we want, and so this format did not have proper serialization. So you could pass a promise to it called the then, and this allowed you to then pass a string with a lot of code that allowed you to do execution. And with this, you could have it throw, I think, it throws an error. You can have the output through throwing an error. So in my example, what I did was I executed shell code synchronously, got the input, and then I threw it through it, so that it produced an error for you, so you can just get the flag. And so I just cat /flag.txt for an hour for that output, and that's how you get the flag that.
Wonderful. Thank you for that. We got a question in the chat, and feel free to ask more questions in the chat right now, and we will take some time to answer them. So one of the questions were, is this considered a beginner CTF? Does it have a difficulty rating? So this is very hard to tell nowadays because large language models and AI is becoming so good at solving these CTFs. So what is easy and what is hard is kind of getting a bit mixed up. Yes, we want this to be a beginner challenge or a beginner CTF. Don't feel discouraged by like these very hard challenges. Focus on understanding like from easy to hard bottom up. And if you have issues, write to us on Discord. But it's hard to tell if this is a beginner CTF. There is no beginner anymore in the like knowledge space. Next slide. Unless we have any more questions.
And if you do have more questions after the stream, please ask in the Discord.
Yes. Okay. What is next? We have other CTFs for you to play. So there are a bunch of Swedish CTFs that are quite fun. Undutmaningen, a CTF by the Swedish government. There's no date yet, but keep look.
There is a date.
There is a date. What's the date?
Wait, one second. It's 21st of March.
Okay, 21st of March. And then Create CTF, I don't think has a date, or am I wrong there also?
I think you're right.
Okay, and then Midnight Sun is going on from, their qualifiers is at the 11th of April. And then we also have the Swedish Cybersecurity Challenge, which is a qualifier for Swedish nationals that want to get into the Swedish National Hacking Team. The Swedish National Hacking Team then competes in the European Cybersecurity Challenge, like the European Championship of hacking, and also the International Cybersecurity Olympiad, which is where we compete against like all other countries. So if you qualify for SNHT, you will get to travel to both Germany and Australia this year to compete internationally. And if you didn't qualify for Säkerhets-SM, it is not, you should not give up. There's still opportunity to qualify to the Swedish Cybersecurity Challenge, even though you didn't qualify to Säkerhets-SM. And then we have some recommendations on where to practice. So pwn.college is a very good website to learn binary exploitation. Yes. CryptoHack is a very good website to practice cryptography. And there's a lot of CTFs at ctftime.org. You can read good web articles at Portswigger.
No, don't do that.
Okay, don't do that.
No.
No, don't read at Portswigger. And we want to thank our sponsor, FRA, and those who qualified for the finals will get to meet the FRA in Stockholm later. So big shout out for them for giving us money to bring you to the finals. And we would love to get your feedback. So please fill out this form so that we can know what to do better next year. I think that is it from us this time. If you have any more questions, ask in Discord or in the chat. We got a question, why is Liam so handsome? I don't know. That was a question from Alvin 765.
Problem.
Will we receive emails for the finals? Yes, we will email you. Not tonight, but in the coming weeks, we will sort out the logistics so that you get tickets to Stockholm, etc. Another question, is Liam some kind of genius? Yes. Yes, he is. Great. Thank you so much. Have a great rest of your evening and lock in. No, now is not the time to rest. Now is the time to upsolve. Upsolve without LLMs, upsolve with LLMs, learn more, go to CryptoHack, go to Pole College. Please grind for your life. And bye-bye.
Bye bye. Bye bye.